Hey, Lily.
Hey, Miss Sparks.
How are you?
I'm good. How are you? Happy Mother's Day.
Oh, thank you, sweetheart.
You're welcome. How's your Mother's Day been?
It's been good. I've been lazy actually. I took a nap.
That's what my mama did.
Yep, it felt really good. After two graduation parties yesterday, I had one for Mo in the afternoon, um, and then my son-in-law's last night.
That sounds good.
Yeah, so I was good and tired today. Do you have specific ones that you want me to go over, sweetheart?
Not necessarily specific ones. I wanted to go over, so I wasn't here for the day that we went over like questions like 59, and I know you already did those, but can you like explain the formula to me a little bit?
Yes, absolutely. We'll just go straight to that. And then the other thing that I did is I created a second review so that there would be different ones if you wanted me to um if you wanted me to, do more examples just so you could see more examples. If that makes sense. But
Yes.
that's the ones you're talking about, 57, right?
Yes, ma'am.
Okay. Okay. So the formula, I think what I'm going to do is put some of this up here. Hold on just a minute, Liz. I got my dogs. Mo is out with a couple friends, and they just pulled in the driveway, so my dogs are barking and whining. So I'm sorry.
No, you're
About the
good. I
background.
have a puppy who every time I get on the phone likes to bark. So I
Oh,
know exactly how
well,
that
and
is.
most of the time, the greyhound likes to whine the whole time because she thinks she's talking with me in math lab. So I mean, I don't know. It's crazy. Okay, so the quadratic formula. Okay, so first of all, in number 57, what you want to do is get it in standard form. And standard form means that everything is going to be on one side of the equation. Now, some people would actually move the 2a and the 10 over to the left, which I'm one of those some peoples. But some people would just move the 3a squared over to the right. It wouldn't make any difference how you do it. You're still going to get the same answer. So as of right now, I think you're the only one aren't you?
I think so.
Okay, so you tell me what you would do, and that's how I'll work the problem. Do you think you would move the 3a squared, or do you think you would move the 2a and the 10?
I would probably move the 3a squared.
Okay, so what you would want to do then is if you had 3a squared equals 2a plus 10. So you would subtract 3a squared from both sides, and you would get negative 3a squared plus 2a plus 10.
Okay.
And then, so now it's in standard form. Standard form means everything is on one side of the equal sign. Thank you. Thank you. Why, did you tell him it was for your mother or something? Mo just brought me a slushie from Dairy Queen. So, yay! Lily Pasco. Everybody say hi to Lily.
Hi, Lily.
It's
Hey.
Nathan Elrod and Emily Elrod and Momo.
Oh, hey, y'all.
So once it's in standard form, you then pick out, your A and your B and your C. So you have to identify those three variables, okay?
Okay.
So A, B, and C. So what is A here? It's the coefficient on this.
It's the coefficient. It's -3, right?
Yes, ma'am. Yes, ma'am. Good job. And the coefficient here is B.
And then it's 2, and then C is 10, correct?
Yes, ma'am. Good job. So that's the next thing you do. So think about it standard form first, identify A, B, and C second, and then you're going to be plugging all of the values into the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So you're going to take all of these values that we've just identified and we'll plug them into this formula.
Okay.
So we have x equals the opposite of 2 plus or minus b squared, just 2 squared, minus 4 times negative 3 times 10.
Okay, that makes sense.
All over 2 times negative 3. Okay?
Okay.
All right, so now you've got everything plugged in, and what you want to do is definitely don't skip any steps in any way, shape, or form. Okay? Just take it step by step and solve each piece kind of as you go along, because this is where there's opportunities for lots of simple mathematical mistakes. So we don't want to work this big complicated problem and then stumble there. So negative 2 plus or minus, and then the 2 squared is 4 minus, or actually you don't want to even write that yet, Lily.
Okay.
You want to look at negative 4 times negative 3, okay?
Okay.
Right here, negative 4 times negative 3.
So 12.
So it's a positive 12. Good job. And then positive 12 times 10 is 120.
So it's 4 plus 120
Yes, ma'am.
over negative 6.
Good job. So now we'll actually combine what's underneath the radical to be the square root of 124 all over negative 6.
Okay, that makes sense.
So now what we've got to do, you can't just pull the 124 out of the radical, okay? We have to factor that. So we'll factor 124 right over here. So that's going to be 62 and 2, and then 31 and 2. And remember, pairs make squares. So we only have a pair of 2's. So that part can come out of the radical, and the 31 stays in. This part right here stays in.
Okay, and then you put that over negative 6, right?
Yes, ma'am, you do. So now what we're going to do is reduce by figuring out what goes into negative 2 to negative 6.
2.
That's absolutely correct. So that's going to be x equals negative 1, because 2 goes into negative 2, negative 1 times, plus or minus, and then this is going to cancel and be a 1. But you don't have to write the 1. You can just write that root 31, and then that's going to be all over negative 3.
Okay.
So if you look up, you've got negative 1 plus the square root of 1 over negative 3, which this negative right here and this negative right here actually cancel, because a negative divided by a negative is a positive. Does that make sense?
Yes, that makes sense.
So that's going to be what your answer would look like. But if you were to write each one individually because of the plus and the minus right here,
okay, that makes sense.
it would look like that.
That makes sense. Would I be allowed to make like a formula sheet for myself and have you like approve it tomorrow and read over it?
I am going to provide this formula, the discriminant formula and the vertex formula to you guys.
That's good.
So is that the one you would be most interested in?
Yes, pretty much.
Okay.
And
Yeah.
then the only like other one that I might be like interested in is like a sheet that helps me remember when to do the different trinomials or like the
Oh,
different.
like you do you still have your factoring brochure?
Yes.
You can bring that.
Okay, that'll be good. Thank you.
Uh-huh. That's what I told you guys. You can bring your factoring brochures. I need to post that on Google Classroom.
I remember you mentioning that, but I wasn't sure if it was like you're like I might allow you to use it on a test or something, so I wasn't sure if that worked for the final or not.
Yes. My biggest fear is I know you did well, um, but I hope those that when I gave the rubrics back, and if they had any errors, I hope that they, were fixing those errors because I don't want anybody to go into the final without good help. Does that
Yeah,
make sense?
yeah. If you post it on Google Classroom, I would just say the errors. I would correct them or something, so then people won't forget.
Yes.
Because I'm a very forgetful person. So if I would have made an error, I would have been like, "Oh, I need a reminder to fix them."
Okay. All right, cool. Then I'll do that. I'll say you can use your factoring brochure on the final, but if there were corrections that needed to be made that were given to you on the rubric, make sure you do them. So I'll post
Yeah,
something of that nature.
that'll be good. Do you mind doing
I'll do 58 and 59 because each one brings a little bit something different to the table that will. But if there's another, is that what you wanted me to do, sweetheart?
yes.
Okay.
Because I think like 58 and 59 were easier for me, but 57 was like harder.
Yes, 57 was definitely harder. 58 and 59 don't really have where you have to factor the radical. So
Okay. So if you don't have to factor the radical, so say like, would you just divide?
yes, ma'am.
Okay. There we go.
You just have to remember that you're going to have like something with a positive answer. So you'll have, because you're going to have that plus or minus. So typically you have a positive answer and a negative answer. Typically,
Okay.
sometimes it can be too positive, even though you're subtracting. Sometimes it can be too negative, even though you're adding. But you know what I'm saying? It just depends upon the size of the numbers, the coefficients, really.
Yeah.
So anyway, so okay. Once again, very first thing you want to do is make sure it's in standard form, and 58 is not in standard form. It has to be set to 0 to be in standard form, and it has to appear as if it's a trinomial with an ax squared plus bx plus c. So 58 is not. So you would basically on this one, it's not going to be as much as it was on 57 to get it in standard form, but it's 4b squared minus 6b equals 70. So we'll subtract 70 from both sides. So it's 4b squared minus 6b minus 70 equals 0. My B and the 6 look a lot alike. Sorry about that.
You're good.
A equals,
4,
yes, ma'am. B equals,
-6.
good job.
And then C is -70.
Yes, ma'am. Good job. So X equals, and the opposite of B. Oh, my sixes and my B's look eerily alike. So the opposite of B plus or minus, try and make that look more like a 6. And then B squared minus 4 times A times C.
Okay, so the first thing, and then divided by
2 times A.
Okay, so 2 times 4.
Yes, ma'am.
So we would start, I'm going to try and do is simplifying it. And so first we would write down the -6 or
Yeah,
positive.
that's going to turn to a positive 6. Good job. I heard you say that.
And then you would have the positive or negative sign. And
Yes,
then
ma'am.
You would do 6 squared, or would you just leave it?
No, you could go ahead and simplify that. Negative 6 squared.
Okay. I don't have my calculator with me,
It's
but
36.
30. Okay. Okay. I was like
So
making sure.
because negative 6 times negative 6 would make it positive. And
Yes.
so it's still a positive 36. And then what you would want to do is you want to look at that negative 4 and remember that. So
Then you'd
negative,
have negative 16
yes, ma'am.
times negative 70. And I
Good
don't have a
job.
calculator with me either right now. So I don't know negative 60 times negative 70, but whatever number that is, I might have something.
1120.
Okay.
So positive 1120. You'll definitely want your calculator because this is something I said in class and I don't know, I emphasized it in some classes more than in others. So I'll definitely say it again. I went straight into factoring that 124, I think, because I've done these problems so many times. So I absolutely know that, there's negative or 124, not negative, but the square root of 124 is not like a perfect square. But when you get to this part right here, Lily, you'll definitely want your calculator with you, Angel, and you definitely want to check to see if this 1156 is a perfect square.
Okay. My
Okay.
dad allows me to use calculators on like finals and stuff or like on tests.
Yes.
So I should be good with that. I just don't have one in my room with me at the moment.
Okay. So what you do to do that, is just plug that in your calculator,
Yeah.
And then so you would do 1156 and then check to see it's the square root. And it is a perfect square. So before you start to factoring, that's when I made the joke in class. I know all of you would just really love to factor the number 1156. But please check to see if it's a perfect square first. And I hate to take the fun out of it. Everybody thought that was real funny because no, none of y'all like to factor that much. But 6 plus 34 is 40 so you want to use the plus first. So that's 40 over 8, which reduces to 5. And then 6 minus 34, which equals negative 28 over 8, which equals 7 over 2, which is the same as negative 3 1/2. So your answer is C.
That makes sense.
All right.
I think I'm like good on those because I got 59. That one was like the easiest for me.
Okay. Yeah. Because good. And what did you get? What is it? C? I can't remember if it's B or C. I know it was one of those two.
I think it's C.
Yeah. Yeah. I can't, I really, isn't that terrible? I can't remember, but.
Okay. I'm trying to make sure there isn't anything else to do. Just as a quick, like, little refresher, do you mind doing like a binomial and then a like trinomial, like FOIL type thing?
Oh, no, not at all.
I just want to review it really fast before the
Do
final
you want a
tomorrow.
FOIL or factor?
Factor.
You want a factor?
Yes.
Okay.
So any problem like that will be good with me.
Okay. So we'll start with like 28. Is that good?
Yeah.
Okay. So what you're looking for, we'll do a few through here. Okay. So what you're looking for when you're factoring is you're looking for two factors that multiply together on number 28 that multiply together to give you a positive 25 that when you combine them, you would get a negative 10.
Oh, so -5 times -5.
Yes, ma'am. So good job. So you would have n minus 5 times n minus 5, which can also be written like n minus 5 squared.
Okay. That's
All right.
easy. Could you
All
do
right.
like, you
And
could
number
skip to
29, This is the difference of squares. So what you're going to be looking for, difference means subtraction. So there would be a subtraction sign in between the two numbers making up the binomial. Then the next thing that you would check for is that both the first number and the second number are both perfect squares. That's why they call it a difference of squares. They have to be perfect squares, and it has to be a subtraction problem. So 25m squared is in fact a perfect square, of which the square root is 5m, and 9 is also a perfect square, of which the square root is 3. So then what you know is you write down both the 5m and the 3 twice, like that, with no symbols in the middle, and you write a plus in one and a minus in the other. So D is your answer.
Okay, that makes sense, but why couldn't it be A?
Because that middle term, if you think about it, 5 minus 3.
Oh, it would make it a positive.
Yes.
Negative times a negative.
Good job.
Okay, that makes sense.
And you would also remember with FOIL, with first, outside, inside, and then last, or I should have done that one on top. That would make that 25m squared minus 3m minus 3m plus 9. So that would actually make that
Okay,
like
that makes sense. That makes sense.
So the difference of squares, if I were to do the same thing to this, Lily, it would look like this. And these two would cancel out, leaving just 25m squared minus n. Minus 9. I'm sorry.
You're good. And then could you just skip and do like 41 or 39, one of those two? Because then that one's one with 3 terms.
That yes, where you have to slide and divide.
Yes. So there's slide, divide, and then you only do bottoms up if there's like a negative on the bottom of like a fraction.
Uh-huh.
Okay.
So I'm going to do And how are you on grouping?
I feel like I'm pretty good on grouping. I'm like good on grouping and foiling, I feel like.
Okay.
And in graphing, I feel like I'm pretty okay with, just because after you do the math, it's just what the math tells you to do.
Yeah. Okay. Good job. All right. Was your preference 40 or 41?
Either one is fine with me.
Okay. Well, I'm going to do 40.
Okay.
40, the first thing you're going to do is factor out a 2.
Okay.
Which is then going to give you 2x squared plus 13x minus 24. Okay?
Okay.
Then you're going to slide and multiply by 2, which would give you x squared, and you got to bring that 2 down, plus 13x minus 48. So I'm looking for two factors that multiply together to give me a negative 48, that when I combine them, give me a positive 13. So that's going to be x plus 16, x minus 3. And then I'm going to divide, because I slide here and multiply by 2. So I'm going to divide and divide by 2. That's not because I divided by 2 here. It's because I multiplied by 2 here. Okay?
Okay.
X plus 8 because that's a perfect integer. This is not, so you bottoms up. 2x minus 3.
Okay, that makes sense.
So it's this one.
All right.
And if you want to write these, I don't know if you know where your factor brochure is, but if you want to write these additional examples down, you're welcome to on your factor brochure.
Okay.
Like if you just want to do that on a piece of paper and stick it in that factoring brochure.
Okay, I'll do that.
Is there another one you would like me to do?
No, I think I'm good.
Okay. All right. Well, just let me know. And if you, like I say, I'm going to give you the quadratic formula. I'm going to give you the vertex formula, the opposite of B over 2A, you know, where you find the axis of symmetry.
Yes.
You know what I'm talking about there?
Yes.
And I'm going to give you the discriminant formula. And remember, just as a reminder, if it also has to be in standard form. And this is the discriminant formula right here. And if it's positive, it's two real solutions. If it's negative, it's two imaginary. And if it's 0, it's one real.
Okay.
So positive is two real, negative is two imaginary, and 0 is one real.
Okay, that makes sense.
Okay. And it's just basically what's under the radical of the quadratic formula, but I am going to distinguish those and give you those on a piece of paper. Okay?
Okay. Thank you so much, Miss Sparks, for taking time out of your Mother's Day.
No problem. I'm happy to do it. The math mama will come in and can help her math students, her math children on Mother's Day. That's good. All right, sweet girl. I'm praying for you. Know that, okay?
Okay, thank you.
Thank you. Wish your mama a happy Mother's Day.
Okay, I will.
All right. Love you.
Love you.
Bye-bye.
Bye.